Okay, so 5.2 is really going to get more and more into linear regression. We sort of introduced it in 5.1, but we're going to get more into it today and tomorrow. So why does the least squares regression line contain the word least squares? Again, the whole point is we want the line that gives us the minimum square distance of the residuals. So we're trying to make that distance, that residual distance, as small as possible. So if we had pizza and the average amount of fat, would it be reasonable to predict it would have also the average amount of calories? So one important property of the least squares regression line, it always goes through the point x bar, y bar. So again, that's always the average x and the average y. So it'll always go through that point. In the least squares regression line, y hat equals a plus bx, the slope of the regression line b can also be found using your correlation coefficient. So b can equal r times sy over sx. This one is on your formula sheet. So if I get my formula sheet out, we're kind of going to do the rest of this part, this unit. So there's your least squares regression line. So we did mean and standard deviation in chapter 4. Here's your least squares regression line. This is to help find the y-intercept. We'll get to that in a second. So you always know y bar equals a plus b times x bar, because x bar, y bar is always in your equation. This is the correlation coefficient. Here's your slope. Okay? So what we're going to look at today is how do you find the least squares regression line if you're not given the data? Because a lot of times in this class, I don't have time for you to put 50 numbers in your calculator. So there's other ways to find the least squares regression line. So we're going to look at 2 other ways today. So if once we know the slope, we can use the fact that it goes through x bar, y bar to find the y-intercept. So basically I want to do y hat equals a plus b, x, y bar, and I'm going to solve for a. So it kind of goes back to algebra. So I'm going to use y bar equals a plus b times x bar, and I'm going to solve for a. So the following is an old AP exam problem. We have an x and a y, and we're given some data, but then the dog ate the rest. But we do know the average x, the average y, so we know x bar, y bar, and we know the standard deviation of x and y, and we know the correlation coefficient. So I can find my least squares regression line if I know all 5 of these. So it's kind of a 2-step process. And you only have to do this if you're not given all the data. So the first thing you're going to do is find your slope. So I'm going to use this equation to find my slope. So b equals r sy over sx. Okay, so b will equal 0.78 times 3.14 divided by 8. Oops. 3.14 divided by 8 times 0.78. So here my slope is, let's round, 3.06. Now, once I find my slope, my second step is to find the y-intercept. Okay, so we have a slope and we have a point. So go all the way back to algebra and plug in your numbers. So I'm going to say 15 equals a plus 0.306 times 7. So I'm again using y bar equals a plus b x bar. And I'm going to solve for a. So 15 equals a plus 2.143. So a is 12.857. So then my equation, y hat equals 12.857 plus 0.306x. Now I don't know what x and y are, so I'm not going to define them. Okay, so this is one way to do it if you don't have the data, but you're given these 5 things. Okay, now most people forget how to do this, but again, it's all on your formula sheet. Now, the second example here is, okay, now we have all the data. Let's kind of review what we did yesterday. So again, your first step will be to put the data in your calculator. So I'm going to go to Stat Calc 36, 48, 51. And this is age in months and height for toddlers. Okay. So I'm going to go to Stat Calc number 8. So there's my equation. Now I'm going to write it out so I don't have to define my variables. So I'm going to say the predicted height equals 71.95 plus 0.383 repeating times the age. So find and interpret the correlation coefficient. My diagnostics were on, so it's right there, 0.994. So R equals 0.994. You're going to have to write kind of small. So there is a strong positive linear relationship between height and age of a toddler. Okay, so again, strength, direction, linear, context. Interpret the slope. So for each additional x, what do we predict happened to y? So for each additional month in age, we predict a toddler's height to increase 0.383 repeating centimeters. Predict the height for 40 months and 55-month-old. Both of those are within our range of our data, so we're okay to do that. We don't have to worry about extrapolation. So again, you're going to do y hat equals 71.95 plus 0.383 repeating times 40, and 71.95 plus 0.383 repeating times 55. So for 40, you should get 87.27 centimeters, and for 55, you should get 93.015 centimeters. So that works out well if you have all the data. If you don't have all the data, but you're given the average, the mean and standard deviation for both x and y and r, you use this. Now on the back is the computer output. So a lot of times, again, we've done Minitab a little bit. You've seen it, but you won't actually ever have to do it. You just have to read it. So this is a computer output for, again, blood pressure versus age. Let's pretend this is not there, because sometimes, most of the time it's not there. So here's a few things that you need to know. We're going to get to a lot of this by the end of the chapter. This should say predictor, constant, age, and S. So keep this handy. I'm not going to go over everything today, but there's a few things you do need to know. So if you're given the Minitab output, the biggest thing you should know is the constant coefficient, 81.05 right here, that's your Y-intercept. So right away you know your Y-intercept. And then see how, that's fuzzy. It says age here, that's your X. So whatever, this will change depending on the problem. And then what this one is, this number here is your slope. So there's your Y-intercept, there's your slope. And then the only thing we really know so far is R. So don't ever use R squared adjusted. I think it's a trimmed one. I'm not exactly sure. Don't ever use it. So this is R squared. So what I would do to find R is I take the square root. So I'm going to take the square root of 0.804. So my R value here is 0.8967. And the only issue here is R squared is always going to be a positive number. R can be both positive or negative. So it's always going to be the same sign as the slope. So if the slope was negative, this would be negative. Because obviously if it's a negative correlation, you're going to have a line that's negative. So these are all you need to know for now. As we go throughout the chapter, I'm going to reference back to this. I will tell you, like, SE coefficient, this stuff we'll do in chapter 13, so you basically can ignore it. This T and this P stuff, again, we're going to do second semester, so you can ignore it. The bottom part, the variance part, we'll get to later in the chapter. So for today, really just focus on that first column. So this is how you would find the linear regression line if you didn't have any data at all, you just had the Minitab output. So 3 ways to find it today.